Hi all, this is your Ratna Kishore. In this video, I will explain the basics of probability by considering some set theory and fundamental axioms. I start the video with some definitions. Trial. A single performance of an experiment is called trial. For every trial, there is an outcome. The set of all possible outcomes for any given experiment is called as sample space. It is represented by S. We can consider the sample space as the universal set for the given experiment. In a single die tossing experiment, the sample space is the set of total 6 outcomes. If we consider 2 dice tossing example, the sample space is the set of total 36 possible outcomes. An event can be defined as subset of sample space. If multiple events have no common outcomes, then they are called mutually exclusive. Consider playing cards as an example experiment where the sample space is set of total 52 outcomes. Here some example events are drawing a spade. This event is subset of total 13 outcomes. Drawing a king. This event is subset of total 4 outcomes. Make a note that if an experiment with total n possible outcomes can have up to 2 power n events. The probability is defined as a function of an event and returns a non-negative number. Here the first example represents the probability of an event E1 and the second example represents the probability of getting sum greater than 20 in an experiment, in which the event is specified explicitly. While choosing the probabilities, we need to ensure that the following 3 axioms are satisfied. Axiom 1 states that the probability of any event must be a non-negative number. Axiom 2 states that the probability of entire sample space by considering it as a single event is unity. Axiom 3 states that the probability of union of n mutually exclusive events is equal to the sum of their individual probabilities. Now consider single die tossing experiment with the sample space S of 6 possible outcomes. Then we can assign the probability of each possible outcome as 1 by 6. Now we need justification for choosing the probabilities by cross-checking with 3 axioms defined. The probability of each outcome is 1 by 6 in our case, which is a non-negative number. Then axiom 1 is satisfied. Now let us consider the probability of the entire sample space. Then the probability of the sample space P of S is equal to probability of union of all the outcomes. From axiom 3, we can write P of S as sum of individual probabilities. By substituting 1 by 6 at each probability, we get unity. Hence, we can say axiom 2 is satisfied. As a conclusion, we can say that if the sample space is having n possible outcomes, then the probability of each outcome is 1 by n. To summarize the method of modeling the experiment, we have 3 steps. In step 1, we need to define the sample space, which is nothing but the set of all possible outcomes. In step 2, we need to identify the events we are interested in. In step 3, we have to assign probabilities to all the identified events such that all the 3 axioms are satisfied. Consider an example experiment to model. Observing sum of numbers showing up when 2 dice are thrown. Here step 1 is defining the sample space. So this experiment, the sample space is consisting of total 36 outcomes, which are shown in the table below, where each outcome is assigned the probability of 1 by 36. Here note that in each outcome, the first value represents the number on the first die and the second value represents the number on the second die. As part of step 2, we are interested in two events. Event 1 is the subset of all outcomes where sum is equal to 4. Event 2 is nothing but the subset of all outcomes where sum is greater than or equal to 10. In step 3, we need to assign the probabilities to the events. Here the probability of event 1 is the probability of union of 3 outcomes. All the 3 outcomes gives us the sum is equal to 4. From axiom 3, we can write the probability of event 1 as sum of individual probabilities of these outcomes. Since each outcome is having the probability 1 by 36, by substituting that in this equation, we will get the probability of sum is equal to 4 as an event 1 by 12. Next, the probability of event 2, which is nothing but the probability of union of total 6 outcomes, where all these 6 outcomes are giving the sum which is greater than or equal to 10. Since the probability of each outcome is 1 by 36, after substituting that, we will get the probability of event 2, where we are getting the sum greater than or equal to 10 is 1 by 6.